go through factoring. Okay, so we're going to start out, today we're going to focus in on factoring quadratics for the most part, or quadratic in form. So look at this one, x squared plus 2x. X squared plus 2x. First of all, before we start doing this, there's an easy way. Let's just, first of all, always look at our problems and see if there's something in the very beginning in common that we can factor out. What do we have in both terms that's in common? X. Okay, so let's factor out an x. Everybody pay close attention, because if you can't factor, you're not going to be able to pass my class. Okay, because we are going to be dealing with factoring the rest of the year. So first thing, we have an x in common, so we're pulling out an x. Now we always want to pull out the greatest thing in common, and you're right. It's an x in this one. So guys, when we pulled out an x, what we did was we divided an x out of each term. So let's write what's left in the parentheses. X squared divided by x. X, and then positive 2x divided by x. Plus 2. Now you'll look, are your factors linear? Degree 1, are they? Yes, so we're done. We factored it, yay, to its linear factors. Wasn't that quite easy? Yes or no? Yes. Okay, awesome. Let's do another one. 3x squared minus 9x. What's the greatest common factor? We want to factor it out. A 3 and an x. So there's a 3 in each term and an x. So we're pulling out a 3x. So now if you need to know what you're writing inside the parentheses, go back through and divide each thing by what you factored out. 3x squared divided by 3x. 3 and 3 are gone. X squared divided by x. X. All right, negative 9x divided by 3x. Minus 3, good. Negative 9 divided by 3 is negative 3. X divided by x is 1. Are these linear factors? Are they both degree 1? Yes, so we're done factoring. Now, if we said solve, then you would set those linear factors equal to 0 and solve, right? But I'm just asking you to factor today. Awesome, yeah. Good, that's the attitude. All right. No questions on this. We're all good. Okay. Okay, so now I'm teaching you the big aha moment, the big trick, and it's going to be awesome. You can use it all the time from here on out. And it's a quick trick to factor things, but you can only use it. The only reason I don't teach it in the beginning is because the students don't learn how to long factor, and there are times when you have no other choice but to long factor. So, quick factoring. This is the only time you can quick factor, and I'm going to make you all take a vow to not quick factor unless you can, because you'll get the wrong answer otherwise. So, quadratics have the form ax squared plus bx plus c, where a, b, and c are the coefficients, the number in front of the variable. All right, the only time we can quick factor is if our a value is 1. So, for example, if we have x squared plus 2x plus 3, can we quick factor? Yes, a is 1. What about 2x squared plus 3x minus 4? Can we quick factor? Yes. No, that a value is a 2. Does everybody understand the difference?
So you have to have a 1.
It has to be a 1, and this is the interesting fact for you. It has to be positive 1. Can't be negative 1 even.
So doesn't x squared equal negative 1?
Positive 1.
Okay.
Yeah, so if a is equal to positive 1, it's the only time we can use it. So everybody, let's take a vow. Repeat after me. I, student, will not quick factor unless a is 1. I swear. Okay, awesome. Okay, so let's do this first one. Can we quick factor it?
Yes.
Okay, so now I'm going to teach you what quick factoring is. So first of all, you have to start out the problem just like we would if we were long factoring. The first step is to say, okay, it's in standard form and it's quadratic. So we factor quadratic equations by saying what multiplies to be a times c and adds up to be b. Well, before we do that, let's list out what a, b, and c are. What is a? What's b? Negative 1, and c is negative 6. Is everybody okay with that? Okay, so we're doing what multiplies to be a times c. So 1 times negative 6 is? So what multiplies to be negative 6 and adds up to be negative 1, right? Is that what we're looking at? Then we list out our factors of 6. 1 times 6, 2 times 3. Now let's take the correct factors that would add up to be negative 1. How about 1 and 6? No, they can never add up to be negative 1. How about these two? But our negative would need to be with 3. Let's check it. 2 times negative 3 is negative 6? And 2 plus negative 3 is negative 1. So it works in both cases. So our factors are positive 2 and negative 3, right? So this is how you quick factor. Since a is 1, you know it's going to factor to be x plus 2, because it was positive 2, times x minus 3. And that's our answer. Do you see how I quick factor? I found the factors, and it's going to factor to be those two things in the form of a binomial being multiplied together. Wasn't that quicker than the whole drop and break grouping method? Okay, so from now on, use that if you can. Do you understand how to do it? We're going to do one more. So number 1 on your worksheet, let's do that one together. X squared plus 5x minus 6. First things first, is it in standard form? Yes. Is our a value 1? So we can quick factor. So we're going to do what multiplies to be a times c and adds up to be b. Well, what's a? 1. What's b? And c? Okay, so what multiplies to be negative 6 and adds up to be what? 5. So listing out factors of 6 again. 1 times 6 and 2 times 3. Okay, let's find the correct factors that work to add up to be positive 5. Could 1 and 6 ever add up to be positive 5? Yes, but we would need our negative to be with 1. Now let's check it. Is negative 1 times 6 negative 6? Yes, right? Negative 1 times 6 is negative 6, and negative 1 plus 6 is positive 5. So those two don't work. These two are our factors. Does everybody understand how those are my factors? So my factors are negative 1 and positive 6. So we can quick factor this. So this is going to factor to be x minus 1 times x plus 6. Because I could quick factor. Does that make sense? Yes? You look a little skeptical back there. Do you get it? Okay, awesome. Any questions on that? All right, so only quick factor, practice quick factoring. Oh, looking at this one, last one. X squared minus 64. Can this one quick factor? Yes, right? A is 1. So we're going to do what multiplies to be a times c and adds up to be b. What's a? What's b? What is b? 0 and c? Negative 64. Does everybody see how b is 0? Okay, so we're doing what multiplies to be negative 64 and adds up to be 0. Okay, 8 times 8. Doesn't that multiply to be 64? If we put a negative with one of them, will it add up to be 0? Does it work in both cases? Yes and yes. Your sign has to be correct. So if it doesn't work in both cases, you can't use those factors. Okay, so it does work in both cases. So our factors are negative 8 and positive 8. Yeah? So it factors to be x minus 8 times x plus 8.
How are we going to worry about it?
What?
What are we going to worry about?
The reason we're practicing factoring so much is because we're going to use it very, 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 very much on Monday. And that's only the teeniest piece of doing the whole problem. So if we spend the whole time relearning how to factor, I won't be able to teach you the math. Does that make sense?
Yeah.
Okay, awesome. That's why we're spending this day doing this. Do 1 through 4. Ready, set, go. So that we can go to long factoring. Because this is so important. Now, you guys took a vow, and I and Miss Christensen get to slap you in the face, slap you silly, if you quick factor when not allowed, okay? So, we're going to still have quadratics of the same form. If a is not equal to 1, positive 1, you must long factor. There is no other choice. You will not get the right answer by quick factoring if a is not equal to 1 and you try to quick factor. So, you have to long factor if a is not equal to 1. But really, when we get better and better at this, long factoring won't take super long. So let's go through this. So number 5, I'm going to do number 5 with you. All my examples, I think from here on out, are from your worksheet, so that's good. Number 5 is 2w squared plus 13w plus 15. First things first, check. Is it in standard form? And it is, okay? Now we see that a is not equal to 1, so we're like, bummer, we have to long factor. But it starts out the same way as quick factoring. So the first thing we're doing is what multiplies to be a times c and adds up to be b. So what's a times c in this one? 2 times 15, which is 30. Does everybody understand how 8 times c is 30? So what multiplies to be 30 and adds up to be positive 13? So, if we needed to list out all our factors of 30, we could. But can anyone think of 2 factors that multiply to be 30? 10 and 3. Couldn't that add up to be 13? But both would need to be positive, okay? Now positive 10 times positive 3 is positive 30, and then 10 plus 3 is 13. So it works in both cases. So our factors are, and I'm going to write it over here, positive 10 and positive 3. But we cannot quick factor. So this is the part that we drop and break. But guys, seeing it a second time, it's going to be a lot easier for you. So let's drop and break. So we drop down our n terms. So we're dropping down 2w squared, and we're dropping down positive 15. Drop, you simply drop down the n terms. Is everybody good with that? Now we're breaking, drop and break. You break down, you rewrite your middle term as your 2 factors. But this is what many of you failed on the first test. What can you not forget? This is 13w. So you can't just put 10 and 3. It's 10w and 3w. So you put them in. Order doesn't matter. I'm going to go with 10 first. Plus 10w plus 3w. Does everybody see how we have 4 terms here now? If you're missing a plus sign or something somewhere, or a minus sign, you better check. Because we should have 4 terms. Drop and break. So then you're going to group your first 2 terms. We know how to factor by grouping. Group your second 2 terms, and then focus on each group and factor out what's the greatest thing you have in common. 2 and a w. So then we'll write what's left inside. Now everybody pay close attention. If you don't know, go back and divide each term by what you factored out. 2 divided by 2 is gone. W squared divided by w. W. Positive 10w divided by 2w is plus 5. Is everybody good with that? Now I'm going to ignore that for a second and move on to my next group. In this group, what's the greatest thing we have in common? Positive 3. So we're pulling out positive 3. So then left inside, go back through, divide each thing by what you factored out. 3w divided by 3. 15 divided by 3. Positive 5. Now you have a safe haven. Check it. Are we safe? Safe haven is the same. So we're safe. We've done this correctly. If not, you factored something wrong. Okay, so let's factor that out. Since it's the same, we can pull it out. So we're pulling out w plus 5. Now when you factor that out, you divided it out. And then left was 2w plus what? 3. It's factored. Okay, so really quick, now that we're getting better at factoring, we see it a second time. It's not as long as it took when we first started, which was grandma slow. Okay, that's our answer. That is the most factored form. All right, so any questions? Okay, we're going to do another one together. Are we all good with that one? Okay, let's do number 10 together. 2n squared minus n minus 15. Can we quick factor? No. So we're going to do the same thing. What multiplies to be a times c and adds up to be b. A times c is 2 times negative 15. This time it is negative
30.
Negative 30. And what's b?
Negative 1.
Good. Negative 1. Okay, so now factors that multiply to be negative 30 and add up to be negative 1. 5 times 6. Could that possibly multiply to be 30? But it needs to multiply to be negative 30. So one of them needs to be negative, and it needs to add up to be negative 1. Which one's negative? Good. Negative 6. Check it in both cases. Negative 6 and then 5 plus negative 6. It has to work in both cases. If it works in only one, those aren't your factors. Because there will be times that it works in this one, but it doesn't work over here. It has to work in both cases. Okay. So our factors are positive 5 and negative 6, right? Okay, now we're going to drop and break. Drop down your n terms. So 2n squared. Drop down negative 15. And then we're breaking down our middle term without forgetting. We're rewriting it as our factors, and we're not forgetting the n, right? Okay, so then order doesn't matter. I'm going to put my negative, well, it really is up to you. Maybe we should put, just to make it harder, let's put our 5n first. So plus 5n. And then minus 6n. Okay, so then from here, we're going to group the first 2 terms, and we're going to group the second 2 terms. This presents a really good problem. Okay, now we'll focus on our first group. What do we have in common? and m, that's it. So if we go back through and pulled out an m, we divided out an m from each term. 2m squared divided by m is 2 and a n. 5m divided by m. 5. Are we all good? Now this is where we have to be careful. This is where most people mess up. We have a negative in front. A negative in front. If it was only behind, it wouldn't matter. When we have a negative in front, we have to pull out a negative with our factor. What do these two terms have in common?
-3.
Good, a -3. So we have a 3 in common, we pull out -3. Does everybody understand why I'm pulling out -3? Okay. So divide each thing by -3. So -6m divided by -3. 2m. -15 divided by -3. Plus 5. Now look, our safe haven came out to be the same. If you forget to pull out the negative, our safe haven would have been off by a sign. So you would have known you did something wrong. Does that make sense? Okay, so our safe haven's good. So we pull that out. So we pull out 2m plus 5. So then it divided out. That leaves me with m minus 3. And we're done. Long factoring didn't take that long. A little bit more work. Any questions? Okay, so I'm going to have you do it now by yourself. All the problems except for number 9. Skip number 9. So just write skip on that one. And then do the others. So you're going to do problems 5 through 10, but skipping number 9. No number 9. So practice those for a minute and then we'll move on. Okay, so if we have 4 terms, guys, remember that we factor by grouping. So if we have 4 terms, meaning 1, 2, 3, 4 terms are separated by a plus and minus sign, then we're going to factor by grouping. So let's do number 11. 12x cubed plus 3x squared plus 20x plus 5. It's not going to say factor by grouping on the end of level test or on an ACT. It's going to say find the factors that multiply to be this polynomial. So looking at this, the first thing we have to see is 1, 2, 3, 4 terms. So we're going to factor by grouping. Group the first 2 terms, group the second 2 terms. And then we focus in on each group. What's the greatest thing we have in common here? 3x squared. Good. So if we factored out a 3x squared, we divided each thing by 3x squared. So let's see what we have left. Now this is a really good one to do. 12 divided by 3, 4, x cubed divided by x.
X cubed divided by x?
X squared, sorry. Right? This is x squared?
Oh, x
Squared. Right?
Squared.
Yeah, good. Now everybody look right here. This is where like 80% of you missed it on the first test. 3x squared divided by 3x squared is 0, says many of you. What is it? 1. Does everybody get that? Not 0, right? Not 0. Okay, do not do that, or ooh. All right. Okay, what's this one? What's the greatest thing in common here? 5. No, because that wouldn't be the greatest thing. Good question, McKay. We can't just do x because that wouldn't be the GCF, meaning greatest common factor. So NO spells no. Okay. All right, right over here. So we divide each. Well, we have to learn a little English today. Come on. Okay. All right. So 20x divided by 5. 4x, 5 divided by 5 is 0, okay, or what is it? 5 divided by 5 is 0?
0.
Is it?
1.
1. Okay, are we safe? Okay, pull out your safe haven, 4x plus 1, and then you divided it out, so then left was 3x squared plus 5, right? And then guess what? We're not done. Do we have all linear factors? No, that's quadratics. Do we know how to factor quadratics? If possible. So you'll try to factor that one further. And it doesn't factor further. So we're done there. But you would try. You would do a multiplies to be a times c and adds up to be b. And if there's not any factors, then it's not factorable. Does that make sense?
No.
Okay. Okay. Yeah, there's nothing that factors. So that's the most factored form. All right, guys, are you okay with factoring by grouping?
Yes.
Okay, would you mind please doing 11 through 13? Ready, set, go.
Oh, jeez. We're not to that point yet.
I would skip to numbers 11 through 13 and do at least one of those. And I gotta keep factoring some of mine. I think I forgot to do that. 4 and adds up to be 0. Okay. Check, but make sure you're careful because some of them might not factor further, even though they're quadratic. Okay, I'm just going to be honest with you. Number 12 and 13, those quadratics don't factor further, but you could check and make sure. I just tried. I'm like, okay, what multiplies to be those and adds up to be 0, and they don't factor further. So once you get them down to quadratic, they don't factor further. But you would need to know how to check.
Oh, you said that.
No, is it 0?
Yeah.
Oh, you mean further? No. You can pull out a, no? Because 9 doesn't work, but you can pull out a positive 2. Hey guys, oh, this is a good point. Somebody just said, everybody look at number 13. Somebody just said, in the factors, 2t plus 9, they're like, oh, nothing pulls out, so 0 pulls out. But that's not true. What can we always pull out? A positive 1. So positive 1 to the left is 2t plus 9. So make sure you factor that one correctly. That was a good point. Good point to make. Okay, yeah, and then, but you're still like just making up one. Or you're solving one of them. I mean, you don't need to, but if you solve or solving, right? It feels like getting more. Right? Okay, so this makes me wonder, would you know how to solve it? Okay. This makes it in my life.
We're gonna do the back.
Yeah, do the back too, because I've shown you how to do the back. Sorry, do the back as well. How do you do the back? Just factoring, right? So what's the greatest common factor out of each one? So that was like my first 2 or 3 examples. My first 2 examples that I didn't have you factor anything of. Like, with factoring, what do you always check? What do we have in common? The greatest thing. Yes, good. Yeah. Well, yes, technically, but we would just try one. You did it kind of the hard way, but the other time. Yeah, so you have the same answer perfect. You see how you just try it. I'm going to do problem number 15 with you. Holy, I left that. Okay. Number 15. M cubed minus 25m squared. Is it quadratic right now? No, it's cubic. Okay, but what do we have in common in the very beginning? M squared. So we'll factor out an m squared. So divide each thing by m squared and see what you have left. M cubed divided by m squared. M, and then right here, 25m squared divided by m squared. Minus 25. And then technically, we're not down to our linear factors yet, but m squared is just m times m, and then we have m minus 25. But our answer actually would probably be written like this.
I was going to say,
Does that make sense though of how I could rewrite it like this if I needed to? Okay.
Why would you?
That was not bad.
Like let's say, I'm just making a point. Because for the assignment coming up, you might want to look at it like this instead. It might help you. Maybe not. Just write it like this, okay? But what I'm saying is quadratic, we would keep factoring, right?
You call me stupid?
No, never. I think you're a smarty pants.